Hi YouTubers. This is near completion of a 75 cycle series of charges and discharges on a section of graphite, commercially available graphite felt. Here are the parameter settings: 750 milliamp charge discharge. And I have the graphite felt soaked with a deep eutectic solvent, choline chloride urea, 1:4 molar ratio, containing lithium tetrafluoroborate electrolyte. And we have it in the circuit with a 3.7 lithium ion secondary cell because we want to see how the graphite will perform soaked with electrolyte, the solvent, as we go through a minimum of 75 cycles looking for any deterioration or decomposition of the graphite. We work with supercapacitor prototypes. Now, interestingly enough, this is nearing completion. I recorded this earlier today, and it was near completion of a 75 cycle series. The cutoff, 3.00 volts on that lithium ion, and we brought it up to 4.2, and you can see, if I step back, the uniformity of the cycles. And pretty consistent if you look at the capacities for the current, constant voltage with trickle current down to 0.20 amps, and discharge at 750 milliamps to a cutoff of 3.00 volts to protect the lithium ion cell. And we want to just see how the graphite does. Now, I already did a 75 cycle dry circuit, just the graphite section. This is the wet cycle, soaked with electrolyte solution. Now, what about the graphite itself? We treated it with Oxone, O-X-O-N-E, Oxone oxidizing agent. It's used in swimming pools. Potassium monopersulfate, disulfate. I'll put this in the information. So I treated the graphite, the graphite felt in a solution of oxone. And I'll put the details down. I think we left it for a day or two and then thoroughly washed it and dried it. And the performance of it as dry circuit component was pretty good. And you can see the numbers here are pretty good. I will upload in this section here the data later today. I'm recording this on the 24th, I believe, of March. And you can see the capacities and the energies. And of course, that is capacity is in milliamp hours, energy in milliwatt hours, and it's performing very well. We'll be trying it with some other deep eutectic solvents. I want to look in particular at zinc chloride with acetamide, 1:4 molar ratio respectively. It's an interesting DES. It's not an ionic liquid. There's subtle differences. If hydrogen bonding is involved, then generally we're looking at a deep eutectic solvent. And I wanted to take a look at that one. But now is the beginning of modification of graphite, both twine and felt. And Oxone is an oxidizing agent that I've actually uploaded videos probably last year working with some batteries where I used Oxone in a chemical reaction in a battery. So I will upload the data on this, and many people would consider using potassium permanganate oxidizing agent. There are a number of oxidizing agents, and what do they do to the graphite? Well, they generally will introduce alcohol and carbonyl, carboxylic acid moieties on the surface. Of course, it should then modify the surface area, and We'll be doing scanning electron microscopic examinations of graphite materials after these runs. It's only 75 cycles, but if there's going to be a problem, you want to see that problem early on. And if you can go to 500 cycles, then that could be pretty promising. But if something is not going to work well, you want to find out right away. Some of these deep eutectic solvents, some of these ionic liquids that are electrically conductive are not cheap. So we are going up to 4.20 volts to start. Then there's a sharp drop down when you discharge to about 3.95 volts. But the electrolyte solution is holding up. I recorded the mass before and after the run, and we're not seeing any evidence of decomposition or loss, such as chemically deteriorating the electrolyte solution, which is very important here. Thanks for watching. We'll be uploading more experimental results. Bye for now.